All right. So ideally, this should be working right now. I have my OBS open in front of me, but we'll get to that. Let's start with what my goal is, what are we trying to do here. First of all, I'm trying to program in Vulkan, trying to make a rendering engine, and I'll go through like steps on how I develop it, but it won't be the standard thing that you'll find in every tutorial because I'm not intending to go through the tutorial process. So, yeah, first things first, I will be using a CMake project because, you know, multi platform and all of that. Or I could use a basic Windows project, things to think about. And so, in this case, we're going to use the Windows project because I'm not used to it and it will be nice to learn it. All right. And I'll take a console app because it comes with the hello world and we build from there. We'll use semantic compression. You can check it out. There's a blog post by Casey Muratori for it. Project name, of course, is Blaze. Create. And there we go. Very sharper. Shut up. Okay. Now, this is the basic thing. We can just get it running and just check it out, see if it actually produces a result. I don't see any. There it is. Okay. So far, so good. First things first, we need to involve Vulkan into our process. All right. We're going to check how to do that. So, I already have Vulkan installed on my PC. We just need the Vulkan SDK. So, yeah, as you can see, we have this nice little thing. Desktop PC. Console. Yes. They use GLFW to involve Vulkan. We don't want to do that because, well, Vulkan, we load Vulkan with Volk, which is a different loader, meta loader. So if it fails to load Vulkan, if Vulkan's not installed on the platform, there's no issue. Generally, not so much of a benefit using Volk if you're going to always run on platforms that have Vulkan, but it does give you a bit of performance bonus because it hard links each of the functions. So we'll come to that as we go. Anyway, let's actually just go to properties, turn on VC package, use VC package manifest. All right, yes. Apply. Okay. Source file, we have that there. How do we add VC package? Yeah, so you're going to find me actually going through a lot of specification and everything, or how to use things and questioning all of that again and again. First, yes, let's turn on if you have a VC package. So I just need to create VC package.json, right? Add new item. Where graphics. JSON. Let's search for JSON. There's no JSON. Nope. So we will simply put random text file. It is no options to create a text file. By Jove. Fine, we'll just edit it here. vcpkg.json. Add. Of course, it's not a thread. Schema, that seems to be right. Dependencies equals, we have an open bracket here, FMT. So first things first, we're going to add FMT there. it lets us use FMT, which comes with its own little benefits. Build, clean solution, build solution, manifest a specific baseline. Okay, we can check how to create the manifest. Actually, I'm gonna do a little sneaky thing. Oh, wrong. It's wrong device. Yeah, dependencies is fine. Configuration.json, default registry, and there we have it. New item. We use cpkg configuration.json. So we can add the baseline in this, paste that, build solution. It's gonna install VC package, and we'll get to it. Do we have any chat? No chat. Right. We're just setting things up, right? VC package internally uses CMake. It's a plausible idea for us to use CMake is right, but we're gonna stick to Visual Studio built-ins. We might move to CMake later. It's not that hard to actually go from CMake to, say, Visual Studio to CMake. And it's not that hard to go the reverse direction either, most of the times. All right, target link to the queue. It's CMake targets. We don't particularly care. Mostly it's probably just here, FMT, format.h. That was the issue. And FMT, println, hello world. So nothing truly changes, but Unicode support requires compiling with /UTF-8. Project, Blaze properties, C++, general, there should be flags somewhere here. Okay, first let's move the standard up. We're gonna use ISO 1, ISO 20. C language standard, leave it as it is. Enable Enable runtime. No, we don't want runtime type information. It has certain costs with respect to space that it takes, and it does a little bit of dynamic allocation. We don't particularly want that. We're going to run things as if it is more or less C. There is an exception option as well. We're going to quickly also turn that off. It's not here. Level 3, nope. We're going to move it to the max. Enable all warnings. Similarly, minimize errors. Yes. So again, I keep pressing enter, which tends to do the wrong things for me. Okay, all right. So yes, yes, and no. So we want no. We won't be using any of the exception handling. Runtime library, different options. I think I'm going to leave that on default. String pooling. Nope. Minimal rebuild. Again, let's leave all of these advanced stuff. All right, moving on. Save all of that. We came here mostly to add a single option. compile flags. Compile us, and then additional options slash UTF-8. It's logs UTF-8. Apply. Okay. The solution. Nope. GM and Zoom has been deprecated, it says. Let's start this one. Where did we add GM? Here. Enable minimum. Oh, I did it by mistake. Apply. Okay. The resolution. One failed because no accept was used in CMAT. We're going to get back there and fix this. So what exactly happened? Processor, scheduling, language, balance mode. None of that is necessarily important here. So we have the UTF-8 there. Enable all warnings and warnings and alerters. And those are entirely external to us. So perhaps we won't do that. Finland one succeeds. CMAT. So no accept is failing because we don't have an exception handling set up. Again, time to fix that. So generally, sort that information. See because exceptions. No, actually is not going quite well. We leave it on. C++ exceptions do not cost you anything if you're not using it. No. There's if we set here to if we set here to these shouldn't be occurring normally. These it's a very unique edit I haven't faced before. It's mostly because it's actually entirely out. Data limitation of working that is completely understandable as well. Anyway, it's getting printed. So we just leave it as it is. Okay. Now, let's get to Vulkan. We're not going to link to vulkan.dll. Instead, we're going to use Volk. Volk has a VC package, which is Volk, if I remember that here. We can check. Oops, that wrong browser. VC package. Search. Where that one? This one. There's packages and search for Volt. Okay, it's just called Volt. So, Volt has been involved. Now we include Volt project, build the solution, and wait for it to install, and then it will sort itself out, hopefully. Success, work is not found. It does have it. It just was an error it didn't remove. Now, you can actually remove this comment, you don't need it. Now we can start initializing Vulkan. First, Volt initialize, and then it leads to an error. We can test this error, so we're going to actually define a macro, which is vk check. Some people use capitals. I don't particularly care. I haven't using these. Abort if failed. So this takes a particular function. We just call it input. And all it will do here is abort, which is done using assert, where we check if the given input, we have to put in the braces because otherwise, if you have something large, this is a text replacement. If you have A and B and has a lower precedence than equal to, and so the and will actually be done on A and the equal to. So abort if failed, we'll initialize. Use macro assert. Yeah, let's solve that. Or we can go for the traditional VK check, really. It's pretty standard as a macro name. Macro is not used. What a joke. We'll finalize, just it does require that. We're actually going to start off with something directly, which is an overall class for Blaze. It doesn't particularly matter. The main reason I'm using it, actually it'll be a struct for now. Main reason I'm using it is just to have a place to put things together. So void setup. We are going to change the naming scheme. I use a different naming scheme in my other other projects, but I'll be using lower camel case for this. Save to personal, right? Setup, void, shutdown. You can also call it init and destroy. Actually, I'm going to use that now. Okay. And so with this, we can actually create Blaze init. We can say we can check Vulkan initialize, move it to init. We could just as well throw exceptions, right? And to be very fair, Vulkan does have a way to do this. If you use Vulkan C++ headers, we can throw exceptions. But I don't want to. Ideally, I'd like to use no exceptions in this system, even though I left the exceptions out. Oh, yeah. I think it's a EH minus instead of this. Slash EH minus. Die. Okay. Build solution. Let's see if it actually says no value. Okay. Nope. Wrong browser again. MSVC no X flag. No set should. If you don't want exception in the STL that will be linked to my program, do that. This is such a cookies only. That warning means you're not going to need to have a try catch. Yeah, that never important. So this, we will go project properties, CC++ preprocessor. You can add additional preprocessor options. Okay, each configuration is different. You can see debug has this, release has this, and debug underscore debug. All configurations have the different ones. And so what I'm going to do here is I'm going to add the mode exceptions. Right? To be fair, no such thing as C++ without exceptions. Yeah, let's leave it on. Let's actually use exceptions, shall we? It can lead to actually decent code. It's just that exceptions are generally not used in game development. And I hesitate just because of that particular matter. So perhaps this is a good time for me to not care about these things, right? Blaze.init destroy. I know this sounds dumb, but bear with me. All right. Next step, once Volk has been initialized, you can check Volk meta loader, and here's the documentation for Volk. So once it's done, sort of initializing, you load the instance. It actually is Vulkan create instance first and then load with Volk. So not here. Again, in there. Vulkan, so small we can create instance there. It has instance create info. So we need to get create info and allocation callbacks, which will just pass null and instance there. So VK allocation create, so VK instance create info. Okay. Instance create info right there. Create info. Okay, we're gonna use, we can use start, create info, designated initialization. Its type is VK structure type instance create info that if the next is null PTR, we don't need this. So this is one of the things where using the C++ headers are quite nice because they will automatically fill up S type, the next for you. So you only have to fill up the things that you actually want to fill up. The rest are default constructed. But I want to use the C headers because they let me have completely plain old data types, which are useful quite a bit of times. Application info, app info, then create that. Dot designated initialization, VK structure type, create info, and then it's, we're gonna just replace this with application info, not instance at all. So one of the reasons why we use this, the structure type, is so that Vulkan itself is able to figure out what the structure of things is. Here I'm putting in Blaze, but in reality it wouldn't be Blaze. So I'm actually going to make it test application version. So you have VK make API version 0010 as is convention. Engine is Blaze. Engine version is again VK make API version. So this make version, as far as I remember, is deprecated. You see, this make API version 0010. Generally, it's not that hard. You can actually make this version using a struct if you like. And this one we'll use VK API version 1.3. I know there's 1.4 and 1.4 actually has a decent support, as you can check, GPU info. That's the wrong one. GPUinfo.org, vulkan.gpuinfo.org, and you can see Windows. Since we're only targeting Windows, that's all we care about. We need to check Core 1.4 or user features. Services. Devices. Hold on. One of these are properties, extensions, format, surface, stills. And those are extensions. Profile. That too is not exactly what we want. We just want to see Vulkan 1.4 support, right? Features 1.4 support. And it's fairly decently supported. Forgot how to do this. I used to get time when I could do this quite well. So let's also note it. Welcome driver. Yes. Doesn't matter. Point is, Vulkan 1.3 is well supported. Vulkan 1.4 came out in December. It's been 6 months. It is decently supported because a lot of things were already available and they were just promoted from extension to core. But we will not go there. Enable layer count. Now, for enabling layer count, we need to have a window. Right now, we're going to say 0 and null pointer, but this is wrong. Extension counts, most of the times, you do not use extension counts for this. Let's make these constants. What's your problem? Can be made const expression. Okay. You cannot be made const expression. You also can be made const expression. They're not compile time because they're inside a function. Whatever are they doing actually? VK instance. That works. Instance. Okay. So we set up the instance. We get this. We want to VK check. Because we can still have failures here. Right? And we continue. So we can create instance. We can promote this instance to Blaze itself. So copy, move it here. And you'll see with actually we can actually move it into constructor. Yeah, let's actually do it. Let's skip the process of actually using Vulk and use Vulkan headers. It will install, it will tell us that session handling is invalid. I forgot to do that. Good generation, EH values, no. Yes, apply, okay. Build solution. Cannot open walk.h. And expected welcome.hpp, right? We use that. We can instance. Since exceptions are enabled, again, another one of these things where I do not want the old default naming scheme anymore. Save to the person. Right. Save. Vulkan initialize no longer there. You just have this. Again, application info gets converted to the app info. And the rest remains the same, right? We don't need these anymore, which is the cool part of this. This too is reach API version, which is a function which is much better for us. API version again, right? We can see it as better. The moment it's a yes, there's a thing we need which is no struct constructors. If we remove that, we'll actually keep having a constructor station version. Engine name, engine version, API version. Okay, there's a constructor there. Come to the second one, get the same thing, make this recap there, remove structure, remove that. The application info becomes just application info. Enable layer count, enable layer names becomes empty braces because it takes these little things known as array values where it needs flags. So took flags as 0, took application info, which it does require an ampersand to. Enable layer counts in this thing. It takes array no proxy. No viable constructors. Yeah. So oops, this one is not required. This one we give it an empty one. Enable layer names takes nothing there. And that makes it ready. This takes by reference. We don't need we check anymore. It will actually throw an exception. VJ create instances again. VJ create instance. And unused result value because this returns an instance. Okay. And if there is an error, it throws exception straight up. So VJ instance, we have it right there. We're gonna remove this. That gives us that. Since we have done this, might as well create a constructor and a destructor. Let's see the options, shall we? So that is the constructor. Here is Blaze. Destructor becomes Blaze without the void. Instance. Well, didn't we change that rule? We did not remove. Oh, it's the prefix. That's the problem. Save to base personal. It up, right? So that seems to be getting its job done. It will throw an exception, which isn't the most preferable thing most of the times, but it is what it is. Moving on, once an instance has been created, well, actually, go back one step, we need window. We see package JSON, we will use SDL3 for the windows because it comes with a lot of other things which are quite nice. I don't know if it's capital SDL or small SDL. Small SDL. Build solution, let it happen. Totally that in. Yeah, one shared. Compiling file. Yeah, because it needs a dispatcher. Well, it's not because it needs a dispatcher. But anyway, we will stop here.